All right, so this is going to be a bit of a set of notes on two-way tables, and we're going to look at a situation where we have, let's say, two categories that we're going to contend with here. And the first category is going to be gender, so we'll have male versus female, and then we will create a category where we are deciding whether or not people like to eat Kraft dinner, right? So, mac and cheese, there we go. So, like, either they like it or they dislike it, right? So, let's say we have a population of 345 people, and 107 of them land here, 21 of them land here, 19 of them land here, and 198 of them land here. Okay, so there's my population and how it's distributed. So that's kind of enlightening. It kind of gives me an idea. Like, there's more men that like Kraft dinner than women, and it's kind of giving me a lot of information. Now I can reshape this a bit and create what is called uh, a two-way table with margins. Okay, so I'm going to add like some margins to this. Right, so there we go. And why am I doing this? It's so that I can now create some totals, right? So here's my total here, and here is my total here. And if I do some adding up, I can create what are called the marginal values, or the total values on the margin, right? So like 107 and 21 is going to make this 128 in total, right? 19 and 198 is going to make this 217 in total. 107 and 19 should make this 126 in total, right? And 21 and 198 is going to make this 219 in total, which if I go either direction in this, 128 plus 217 or 126 or 219, should get me to my population size of 345. Okay, so this gives me a little bit more information when I add the margins to the 2A table, right? Because I know that the total of the population that like Kraft dinner is 128 out of 345. Those that dislike it is 217, so more dislike it than like it. And there are more women in my population than there are men, right? So, you can see how this is getting like a little bit more able to reveal things. So what I'm going to do is I'm actually going to convert this into what is called a marginal table. Okay, so I'm going to actually take each of these, not a marginal, I'll tell you, a relative frequency table. So here's the term I'm using here is relative frequency. Okay, so relative frequency is just like statistics code for percent of the whole. Okay, so if I look at things, I was going to take the main table here to begin with and say, okay, divide this 107 by the 345, right? So if I divide that 107 by the 345, if I used a calculator there, I'm going to find that that's 31.0% of the whole. Okay, and then take that 21 and divide that by the 345. So I'm always dividing by the entire population, the 345. That's going to give me 6.1% of the whole, right? The 19 by the 345 is going to give me 5.5% of the whole. And the 198 divided by the 345 is going to give me 57.4 of the whole. 57.4% of the whole. So this is like actually giving me some additional information that like I didn't have before. I can actually see like that 107 was actually 31% of all the peoples, right? So that's helpful to know. So like I could just kind of take this section of it and that would be like a relative frequency two-way table. But I probably also want to convert the margins into relative frequencies as well. So one of the things that I want to note here is usually these things are going to add up to 100% if you take them as a whole. Sometimes you might get like 99.9 or you might get 100.1. And that's because there's these are rounded values, right? There's numbers after that 0 and after that 1. I just rounded at the tens place. So be aware that there could be some round off error. So this is why, like, when I go to do the marginal stuff, I don't want to just simply add these and get there, because then I'm doing what's called compounding the error, and that's going to cause problems later on. So I'm actually going to take the marginal value, the 128, and divide that by the 345. Now, it happens to work with this table where there is no rounding errors, but in the future you want to actually start with like as few computations as you can. So if I take that divided by the 345, I'm going to get 37.1%. If I take the 217 divided by the 345, I get, I think it's 62.9% when I look at my calculator there. When I take 126 and divide it by 345, right, let's get rid of that, divide that by the 345, I get 36.5%. And finally take the 219 here, divide that by the 345, and I get 63.5%. And there's like one last obvious piece here, is that if I take 345 and divide it by 345, I'm of course going to get 345 divided by itself as 1, which is 100%, okay, of the whole. So what am I looking at here? I should probably make 100.0, but I'm just going to leave it there. The reality of, because that's not rounded, so the reality of this is that I've now got something that's a little bit more enlightening. I know that like 63.5% of my entire population are women, 36 point, roughly 2/3, right? Roughly a little more than a third are men. Roughly 2/3 don't like Kraft Dinner. A little more than a third like Kraft Dinner. So this might be like something that's useful for marketing values. Like, okay, a third of the people like, a little more than a third of the people like Kraft Dinner, and most of them are men, right? So like, hey, cool, right? So this is where you can get that like conditional probability, right? Because the probability of liking Kraft Dinner, right? Or sorry, the probability of, let's go the other way, of being a man, given that you like Kraft Dinner, right, is 31% out of the 37.1%. Aha, because this is the probability, remember, the probability of being man and like, right, over the probability of like. Haha, this is like making connections here. Right, oops, sorry about that. And let's go in here, grab my calculator. There it is. Okay, so I grab my little calculator here. And I go, alright, so what's 31 divided by 37.1? Right, 37. I'm good with numbers. 37.1, right, is telling me that the probability is like 83.5%. So this is kind of interesting, right? So I got that like from my two-way table using relative frequencies, and having the margins made this pretty simple to figure out. Was that like if I grab somebody who likes Kraft Dinner, the probability that I've actually chosen a man is 83.5% of the time from this population of 345 people. Now note, when you change this all to relative frequencies, you lose info. Okay, because unless I know that the population size was 345, right, I don't know how many people were here, right? I just know what percentage of the peoples were here. So like, as you are summarizing, so it's going to be a big theme in this course, as you summarize information, you have information loss. Okay, so it's a key theme throughout the course and a key theme in descriptive statistics. Alright, so there's like a good overview of two-way tables, and we'll kind of go from there.